All right, let's kind of just do a very quick little recap. Yesterday went over the syllabus, went over the modules, went over the resources, just FYI, don't forget on. There's the attendance deal right there, so you can just take a scan of that QR code. That's how you're gonna do attendance in this class. Very simple. Make sure to put your, fill in your, read the deal, put your last name first, okay, please. So people put it there first and then models where they're at, so. Modules really quickly, we're gonna jump into 1-3 today, but there's an attendance link, if for some reason people forget their phones. Okay, but you can always go right there, that link will take you to the same thing, you can go ahead and do your attendance as well there. Getting started, you only need that full recorded lectures, as you notice right there, when you go to week 1 lectures, there is the lecture from yesterday right there. Now you're gonna see what I see. But there it is right there. Just so you know, that insight right there, that lets me know that you watched it, if you decide to watch it. I don't care if you watch it, it's up to you. But that is usually something I will look at later on when a student inevitably says, I've looked at every lecture and I've watched everything. And I go in and look, I'm like, you've done nothing. So, Desmos, if you have a chance, get in there and start practicing that. We're gonna start getting that pretty quick, because like I said, we're going to be using it, okay? Excuse me. Mainly using it for you. You can use it at home, it'll help you out. It'll actually help you out on some of your homework problems too. It's a good way to check your answer instead of cheating. It's a good way to check it. So practice that. It's super simple. It really is. It's very intuitive. Okay. You won't be able to use it on your midterm and final, just so you know. Okay. So, but it will help you, especially when we get to chapter 5. That's usually when all hell breaks loose in this class. For some reason, chapter 5 people are like, oh, okay. And like I said, of course, today, polynomials and factoring. Just to kind of remember, this class looks a little bit differently. Blank lecture notes today. Once I'm done today, like I said, this is an ITV class by design, which is the way I want it. I'm not filming myself, thank goodness, because I got to lose some weight over the summer. But you will hear my voice if you go look at the lecture video. And so everything you see up here will be on a lecture video posted today, along with my notes. Now, mind you, what I write today on this screen will not match what I write probably completely because everything's organic, okay? There will be a lot more detail that's always in your notes, okay? So you have those to look at. Any questions? So far, so good. Okay, all right. Everybody know how to get into Hawks? Everybody good? If you haven't gotten into Hawks yet, please get into Hawks ASAP, as that's where you're gonna need to be doing your homework at. And just so you know, this is where you find all you can remember, don't look at that to-do list, look at your calendar. And there's how everything is. So by Monday, we'll have done 1-3, 1-4, 1-5. If for some reason, okay, just to let you know, we get hung up somewhere and things slow down a little bit. Now there is gonna be some hard, like we're gonna have to finish stuff. Like we have to be done, we have to have our midterm by there, okay? Just because I know it's coming up after that, we want to make sure we have time, okay? But I will adjust things as needed sometimes. I'll never pull them closer. I may kick it out a day, like say, hey, we didn't get to 3-3 till this day, so I may kick it out to this day or maybe even this day, okay? Just to kind of let you know, but I'll always kind of give you a heads up about that, okay? I will never make things due sooner. Ever, okay? So the soonest you're ever gonna see anything is what you see on this calendar right now. Okay, so like I said, get into that homework, get it done quick, okay? So where would we be starting at? We're technically starting in chapter 13 of intermediate algebra if you took that, except like I said, this is gonna be a little bit more, it's intermediate algebra on steroids, okay? You're gonna see the same type of questions, it's just they're gonna be like, what the crap is that? But when actually, when we boil it down to its base nature, like, oh, okay, I have seen this before, okay? So let's jump in and take a look. Polynomials and factoring. Terminology, let's get through some terminology, okay? Like I said, we're gonna be a little bit more math centric this class than what we normally are, okay? So that means I'm gonna be a little bit more concerned with saying correct words, because like I said, I don't know where some of you are going after this. Is everybody okay just to conserve time if I write mainly just in black, or would you rather it be like in red? It's really up to you. It doesn't really matter. Okay. I can go backwards and forwards. It's a lot easier on my iPad to jump backwards and forwards, but I don't want to waste time going. Okay. So terminology, let's get through some stuff real fast. Let's remember we have the term of a monomial. Hold on, my screen's going black on me for some reason. Of course, day one is going to be, here we are. We have a monomial. A monomial is something with just a one term. Okay, so you might see something like this, 5x squared. That's just one term, monomial. Okay, and then we have something called a binomial. Think. That's something like you might see this, 10x plus 2. Notice it has two terms, so it's binomial, okay? And then we have things called trinomials, obviously. So when you hear me say like the perfect square trinomial, you'll know it's something of x squared plus 2x plus 3, something like that. 3 terms. Anything above that, we call it a polynomial, okay? Hence the name of this, polynomials and factoring. But to be honest, in this class and moving forward, anything with 2 or more, we just tend to just call poly. Okay, now it doesn't mean eventually you're going to hear me not say the word binomial because it's part of a definition or something like that, but just to let you know. Okay. In your notes, I have some other stuff in here, like I have some review, like your laws of exponents, stuff like that. Remember how you kind of add powers together. What I would like for you to remember is notice, can anybody tell me on this trinomial, in fact, I can switch colors very quickly. What is the leading coefficient?
1.
1. Why would it be 1?
There's nothing in front of the.
Exactly. There's a 1 right there. Hence the word leading means it's the first one. It's out front. Okay. We know it has to be because remember everything has to be written in descending order. Okay. You always will put your 2, 1, and 0. That means it becomes something you do and you just get used to doing every single time. Okay. Regardless of what Hawks does, get used to doing that. Okay. Trust me. It's going to help you, especially when we get to like chapter 3 and 4. Okay. What, pray tell, is this called?
A variable.
Very good, variable. What is that called?
Coefficient.
Coefficient, exactly. This, constant. And of course, this right there, as you so explicitly put, is the leading coefficient. Exactly. The reason I'm doing this is I want us to get past some of the definitions now, so whenever I start saying them, you don't start going, oh, what's he talking about? Okay. Also, very good to remember, I will not be writing down all the laws of exponents. When we get to some, I can kind of remind you about them. That is something you would have learned in chapter 12 in elementary and 15, starting in 15 intermediate. So you can always go back and look at those videos. I have a link in my syllabus. It is good to remember some sets though. We have one that looks like this, okay? That's a set of natural numbers. Some books will put it this way. They'll put it in 0 there. Okay, that means they're going to start the naturals at 0. Technically, it'd be whole numbers starting at 0, but a lot of books are getting away from whole numbers, okay, and they just use natural numbers. But remember, this is anything of the set that goes 1, 2, or sorry, 0. This thing is blinking like crazy on me. 0, 1, 2, 3, ... Okay. Then we have, anybody remember what this term is? When you see a Z.
Integers.
Integers, okay? Remember, that's any number, ... of -3, -2, -1, 0, 1, 2, ... Okay? How about this guy right here? But the rationals. The numbers in between. Remember the fractions? Remember what a rational number is? Every fraction is a rational number. Think of the first term. What does the first thing say? Ratio. So that kind of helps you out a little bit. Rational numbers, every single fraction is a rational number, but not every decimal is a rational number. Remember when you got those ugly decimals, the ones that go off to infinity and they just are really, really ugly? Like the square root of 2, if you put that in your calculator, you get 1.41, it just goes off to forever. That will be an irrational, okay? That will sometimes denote with an I, but I don't use that because that's not something we use a lot. Let's put it that way, okay? All of these numbers, though, what would they comprise? Including the irrationals if you add those in as well. Think about it. You learn about it because there is an imaginary part, but there's also a
Real numbers?
very good real numbers. Those are the real numbers, okay? Those are the set of all the numbers that basically you use every single day, okay? And then, of course, beyond that, we have what? You learned about that when you started taking those square roots of negatives? Yes, but the imaginary composes one piece of a complex. Remember the complex numbers. So we extend our number system out to the complex. I won't show you that. It is in your notes, but we have a whole chapter here in a little bit that will go over complexes. Okay? We good kind of right now for some review? Let's do some operations with polynomials because, like I said, this is going to be a lot of like review. This is going to be like, hey, I like college algebra, but this is pretty nice. Then all of a sudden I change chapters. You're like, you're a piece of crap. I really hate you right now. No. Look at these closely. Let's look at A. We have the term 2x cubed y minus 3y plus z squared x, all in parentheses, plus 3y plus z squared minus 3xz squared plus 4. When you have a two parentheses separated by a plus symbol, what can you do with the parentheses? Yeah, you can just drop them. The only thing you need to be careful of is, once again, be very careful of this guy right here, right? Because if he is negative, what's going to happen? You can't just say, well, that's a plus. You can say that's a plus a negative number if you want to put in your calculator that way, right? You can easily do that, but you just got to be careful about that. But that's pretty much all you got to worry about when dealing with, when you have two parentheses separated by that plus symbol, is you can just literally just write this as drop everything as, oops, 2x cubed y minus 3y plus z squared x plus 3y plus z squared minus 3xz squared plus 4. What's my job now? What is the thing that you need to do? Are you done at this point?
Combine like terms.
Combine like terms. And if you've taken me before, this is going to be just like, oh, whatever, I've heard you say this before. But if you haven't, then this is the first time. Be careful, okay? Don't be doing this. As you combine like terms, like let's look for here. Let's look at our 2x cubed y. Is there another one like that one? Anywhere in there? Can you see anything that matches that? No. So we can come in here and put 2x cubed y. And here's what I really don't want you doing. This. People do that all the time. They're like, I got rid of that when it's done. Well, what you've done is erase the evidence. What if you do some bad math? How are you going to check your answer now? Okay. So what I would do, and what I suggest always do, is always have at least two colors. Have a pen and a pen or a pencil, and then whatever color stands out to you the most. Like for me, in writing, it's pink. Really stands out. I can see it. And so I would come here with a pink and just go, that's gone. I know it's gone, but I can still read it. You notice? Okay. Now we come through here. What are we going to look for next? Well, if you want to, I mean, pretty much look wherever you want. I would probably go to this negative 3xz squared. Do we see a negative 3xz squared anywhere else?
No.
So I've got that guy there. Look carefully. They just fooled you. Z squared x is the same as xz squared. All they did was switch those variables around. Okay, so there is there is another one in there, isn't there? It's right here. Remember, this is saying z squared times x, right? Multiplication is commutative. You can go backwards and forwards with it. Okay, so that's them trying to fool you. So no, you do have one. So a negative 3xz squared plus a z squared x, what would that be? Basically, you have negative 3 plus 1, don't you? What's that going to turn into?
2.
Negative 2. Negative 2, and then I would write it this way. Xz squared. Okay, that's how, just so everything goes in alphabetical order. Then you come in here and get rid of those. Look at your y's. You got a coefficient of negative 3, and you got a coefficient of positive 3. What's going to happen there? Yeah, those guys just cancel out completely, don't they? And then notice at this point, we've only got 2 terms left. They don't match, and so therefore we can just jump right in there and just say, hey, how about plus z squared and then plus 4. Notice this is stuff you've seen before. It's just a little bit more difficult. They're trying to fool you now a little bit, okay? B. B we'll start to work on. We probably won't finish it up, but because once you get to one part of it, you're kind of back to the same thing of combining like terms. Do we need to really spend a lot of time combining like terms, or are we kind of good at that? I mean, probably need to refresh yourself a little bit. Be very careful, right? But there is something specific about this one you do need to see, isn't there? What is a uh-oh, watch out on this one? Can you just drop the parentheses?
To distribute the negative in.
Yeah, distribute that negative. You got to take this negative here. I'll rewrite it down here. You've got 4ab cubed minus b cubed c minus 4 minus b cubed c. And she's exactly correct. This is a negative. You've got to take that negative and distribute it in there. Okay. And then whenever you drop your parentheses, you have 4ab cubed minus b cubed c minus 4 plus b cubed c. If you notice right away, this is very simple. Look at this right here. I can pretty much just come in here. Can I just do this? Doesn't this go away here and that goes away there? And all you're left with is those right there. Finish it up, put them together, and happy days. Right? So that is how you're going to be adding and subtracting your polynomials, binomials, monomials. Okay? Well, when we add and subtract, we also got to learn how to do what? Multiply, right? Few ways to do these. I'm going to keep it very simple, but I would like for you to realize that sometimes, now this one doesn't have a formula. It's very close to being a formula. But if you look right here on B, just really quickly before I get to it, had there been a 3 in the second expression, now the reason I'm using the word expression, first off, why am I using the word expression for any reason right now? What is this lacking? Do you see this? So it's not an equation, it's an expression, okay? So this right here is 2 different expressions wrapped inside a parenthesis, okay? So if you notice the second expression here, notice that if I put a 3, a leading coefficient of 3, you have a difference of squares up there. Okay, so kind of start looking for those little differences of squares, especially the difference of squares, that guy pops up. Remember, that's a squared minus b squared. That factors into a plus b, a minus b. Okay, it's not 1 because why is it not?
Three.
The 3, it's got to match. Only separated by a plus and a minus. Okay, so kind of keep an eye out for those. First one, what am I going to do? How would you decide to do this first one here? We're multiplying, aren't we? Are we multiplying this first expression by what? The second expression, right? Well, let's remember that we have the FOIL method. Take it, multiply it out, okay? What I always do, I do it in your notes, I'm gonna do it here. Okay, I come in here and very carefully, it's harder back here because of where this thing's at, I will draw me a little map. So that way I know where to go, right? Completely. Remember, this in red up here. You have something a to the m times a to the n. Same basis, what do we do to the powers? Add the powers, exactly. You got a m plus n. Okay, so let's remember that as we start to do this. So when I come in here, notice my first one's going to be, well, 2 times 4 is just going to be 8. And then notice there is no other variable with that 4, so I can literally just put the x squared y. Correct? Next, I go, okay, hey, I've got 2 times 3. They're both positive, so I'm going to have a positive here. 2 times 3 is 6. And then I've got no x over here, so that's nice. So I'm going to just put an x squared. There isn't a y, but then there is a z, so I'll add the z. Does that make sense? Notice you've done this before. We're just adding on a few more variables. Okay? Keep going. I'm following my line. So I've got 2 times 3, but notice I've got a positive and a negative now. So a positive and a negative always make a negative. Exactly. 2 times 3 is 6. And then I start noticing, oh, look, I've got x squared times x. Well, that's the same basis. The x has a power of 1, so it's just 2 plus 1. So this is going to become x to the cubed. Notice I also have a y, and so that is going to become what? Y squared. And now we move on to the other part. Now we can move on to the inner and go, okay, now we got to start doing this again. Okay. Negative and a positive always make a negative. And that just looks like it's going to become 4z cubed. Negative and a positive will also create a negative, and that's just going to become 3. Oops. 3 again. Negative 3. Oh, but I've got a z there. So what's that going to become? Z to the fourth, exactly. Z to the fourth. And then the last one. A negative and a negative make a positive. And I'm trying to get you, the reason I'm saying this out loud is not for mainly, well, it is for you. But notice I'm going through this in a step-by-step fashion. First off, I'm looking at the parity. Those are the positive or the negative, okay? Are they both positive or are they both negative? Or they're both opposites? I put that down. Then I look at the coefficients or the constant. Multiply those. That goes next. Then I start going through each variable one by one. I don't look at the whole. I worry about the tree. And do it that way. If you look at the whole, you get messed up. Okay? So here, yes, I've got negative and negative. That makes a positive. That's a coefficient of 1 times a coefficient of 3, which just gives me 3. I don't have any x or y's, and so this looks like it's just going to be x, y, z cubed. Do you have anything that matches, though? It's a little messy, isn't it? It's a crib note version. You're done. There is nothing in there that matches. So this is as simplified as you're ever gonna make that. Unless I started giving you X's and Y's and stuff like that to plug in there, you can't do anything with it. Okay? I'll leave B for you to do at home. Or to look at my notes later. So that way we're not hanging out too long. Okay? Greatest common factor. Greatest common factor, remember, when we're looking for the greatest common factor, it's no different than whenever you were deciding to, when you first started to learn about fractions and you saw 2/4. Okay, well, we know that 2/4 is not the most simplified. Okay, what is the simplified form of 2/4? 1/2, but how do you know that? Other than the fact that you've done it so much now that it's like muscle memory.
You can divide by 2.
You can divide by 2. So the greatest common factor between the 2 and the 4 is a 2. And so I would go in there and divide out a 2. Same thing for greatest common factor. Okay, you look through everything, and I always, once again, I do it in order. Well, I'm going to be online to you. First off, I look at the variables. If there's variables going across the whole thing, that's a telltale sign to start looking for a greatest common factor. Then I look, is there one common variable going all the way across? Well, yeah, there is. There's an X. Okay. Immediately my brain goes, okay, I know for a fact I can factor out X. You're always going to factor out the lowest power, okay, of the variable. Okay, well, that helps out. Okay, which for this one is going to be what?
X squared.
Yeah. So I know there is an X squared that can get pulled out, but now we need to be looking at our coefficients. Do you have a greatest common factor amongst those?
2 or 4.
4, exactly, 4. Okay, because 4 can be divided out amongst everything. Okay, so yes. 4. Now hear me, we are factoring, we are not simplifying. Factoring means I see what you pull out because you can always put it back in, okay? Factoring is reverse distribution in a rudimentary way to say that, okay? So look at the coefficients, we start dividing out everything. You can even do it this way if you like, 4x squared, 4x squared, and 4x squared. If you need help amongst that again, you can look here at the rule that you have. If you have a to the m and a to the n, what happens to the m and n?
Subtract.
Exactly, m minus n, okay? In case you need that, okay? So notice you come in here very, very nicely and you go, okay, I'm gonna write a 4x squared and then I'm gonna put a parenthesis right here, okay? 12 divided by 4 is just going to be a 3. X squared and 5, well, that's 5 minus 2. That's going to leave me with x cubed. Minus, well, doesn't that whole thing just go to a what? A 1, exactly. And then plus, okay, a divided by 4 is 2. And then how about x? And then what happens at z cubed? It just stays, right? So you just put a z cubed right there. Could you check? See if you did it wrong. How would you check? Yeah, take this guy, put it back in. When you do that, it should match that right there. It's a great way to check yourself. Isn't that how we check ourselves when we did factoring before? Should always distribute it back together and come back to the original, okay, expression, equation, whatever we're dealing with at the time, okay? Once again, I'll save that for you later. Because I want to make sure we get through everything. Okay, so we factored by, now this is called factor. You can also call this factoring by grouping. Okay, not factoring by grouping, but like, remember whenever I taught you, well, some of you, when we started learning about factoring, sometimes pulling out that GCF, that common monomial, okay, That factoring, you were done, right? That's all you could do, and then that's all she wrote. This is a method right here of factoring. Notice this guy right here, you couldn't factor him, okay? Matter of fact, I'll never teach you how to factor something like that. More or less, I mean, maybe a little bit, but not like that. Okay, so notice this right here, you could technically solve it if you're in Cal 3, but it is factored. Let's look at another one. Factoring by grouping. First off, do anybody remember what factoring by grouping is?
Separating the two
By a one.
terms.
Separating two terms by what? How we separate them? There you go, by parentheses. Okay, factoring by grouping. It is a very good way to do things with. I love it if it works. Okay. Remember, if you had me in the last class, when we got to chapter 16, I said I have taught you every possible way to factor a quadratic. That means there might be other ways. Okay, so always kind of be on the lookout for that. Okay. Yes, my go-to still a lot of the times is going to be the quadratic formula. Sometimes. Okay. Notice carefully though that this one you could start trying to factor by grouping, but there's a problem. Okay. Notice this guy and this guy. Their y's separated too far apart. So why don't we rearrange those y's where they're together and then put the x's together? Okay, we can do that. So let's come in here and rewrite this as 6x squared plus 2x, and then minus y minus 3xy. And then we can do our grouping, which is, as stated, separate them into two different expressions. And be very careful. I'm going to rewrite this again because I'm trying to do a lot of warning now. Oops. Scrolled up on me. Second here. Because most of you are probably not going to change colors, let me do this in black like you probably do it. If you're not careful, this is what I see people do a lot. And what did you just do? By accident, of course. That looks like a positive now, doesn't it? Okay. Now, right now in class, you're going, whatever, dude, I know that's a negative. Yeah, but how about on a midterm? When you're already worried and your anxiety's already high. So let's just be very careful and very intentional in this class, okay, not to do things like that. And let's put our parentheses very carefully on the outside of that operator there, okay? And then we start coming in here to each expression and we start finding the common monomial of each expression, okay? So what would be my common monomial for the first one?
2x.
Very good, you got 2x. And then you put your thing back. You can come in here, divide by 2x. Some people need this. 6 divided by 2 is 3. That's going to give me an x plus 1. Is everybody good with me doing that pretty quick? Well, how about the next one? There is a rule staring you in the face.
You have to drop the negative.
You have to factor out the negative. You're right. You have to factor out that negative no matter what. You cannot have a negative out front. So no matter what, I am pulling out a negative. But negative what?
Why?
Yeah, so let's pull out a negative y. Coming here, I've got negative y divided by negative y. Well, a negative and a negative make a positive. Y divided by y is just 1. The next term says negative and a negative. That is a positive. Then I got 3. And then x. And then what happens? That y is just gone, right? He's a 1. He's not gone. Don't use the word canceled out when dividing because we don't cancel things out when we divide it. It goes to a 1. They reduce to a 1. Canceling is what you do whenever you're adding and subtracting. 5 minus 5 does cancel, right? Because it goes to a 0. But 2 divided by 2 goes to a 1. That's not canceled. There's a 1 there. We just don't show the 1. Okay. So notice, are we done here? Look at it carefully, or do they match? They do, don't they? These guys just are what? Oops. Yeah, just flipped around. So these guys match. hear me out. Most of the time, 99% of the time in hogs, these are gonna match. If you organically create something though, like later on, there's gonna be some that won't match. I'll show you why that happens, okay? So, but 99% of the time they match, okay? But if it doesn't ever match, first off, if it doesn't match, go back and check your math real fast, okay? In the very few instances that it doesn't, one, that won't be on a midterm. Two, I'll give you fair warning in your homework examples. I'm like, this is why this one didn't match. And I'll put it in the notes and we'll do it in class, okay? So notice we were right. I can come back in here and go, okay, well, I have 2x minus y, and then I have 3x plus 1, and that guy is now done. Could I check it? How? The foiling process. Remember the foiling process you just learned or just remembered? You haven't just learned that. Same way. You can always go back and check. Continuing. Anyway. Factoring special binomials, okay? Remember, these are those special formulas that you learned about, okay? You have some special formulas here. I'll run them off to the side. Check for these, okay? It's always a good idea. Check for special formulas. If need be, yes, you have the ability right now at your level to factor some of these without having to do this. But the special formulas are a little quicker sometimes, okay? Remember, we have some. We have a difference of squares. Anybody remember what that is? I literally just said it. A squared minus b squared, right? Is all equal to, what does that factor to? A plus b, a minus b, right? You also have a sum of squares. Which if we're gonna call this factoring, now hear me out. Factoring, not solving, factoring a sum of squares. Does anybody remember what that factors into? That exactly, it's not factorable. It is solvable, but it's not factorable. That's the one that if you actually try to solve it, you're going to end up having to have a square root of a negative. And we know we can't do that. But because we have the square root method that you learn later on, you can solve it, but it's not factorable. You also have a difference of cubes. You have a cubed minus b cubed. That turns into a minus b, a squared plus ab plus b squared. And then we have a sum of cubes, which is a cubed plus b cubed. And I apologize for my handwriting. Running on a big screen, it's getting lower toward the bottom of the screen right now, so it's a little harder to write. A plus b, a squared minus ab plus b squared. Let's do the first. First, pretty straightforward, isn't it? Is that a difference of what? I know it's a difference because I see a what?
Subtraction.
Fraction. Does it match anything, really? Yeah. Well, is 49 a perfect square?
Sure.
Yeah. 7 times 7 is 49. Can you use your calculator to check if you need to? Amen to that. That's why you got calculus in this class. Don't forget, I will be showing you how to do fractions with these two as well. Okay. X squared is a perfect square, isn't it? 9 is a perfect square. What times what equals 9? 3. What about that 6?
Always right.
Think about it this way. What if I took the square root of y to the 6? Remember how to simplify those? 2 will go to 6 how many times?
3.
3. Well, doesn't that mean everything comes out? Right? Nothing's left inside there anymore, right? So would this just turn into y cubed? So therefore it is. So be careful about that. So when you see an even power and you're talking about perfect square, be careful about that. Because those evens will pull out because the index will go into that number an even amount of times. So just notice when I take the square root of this number, we're going to have what? If we're going to have a perfect square or a difference of squares, we can separate with a plus and a minus, right? The 49 will go to a 7 in both. X squared will go to x in both. 9 will go to 3 in both. But then that y, because we can take the square root of it and it all comes out from underneath the radical, that just becomes y cubed. Why does that work? Because y times y, or sorry, y cubed times y cubed is what? Same base,
You
add the powers. What are you going to get? Y to the 6th. It works. Notice as I stated, it's the same stuff you learned in intermediate, or you learned prior. It's just tweaked, right? It's a little different. You have to stretch your brain a little more. Now we're combining things from all over the place. Okay, so. Here, we're going to get this, we'll do this very quickly. This would be what? A difference of cubes. I got it kind of right there at the very upper corner so you can see it. How I like to do these, the cubes, okay? I know I have an A and I know I have a B, okay? So for my A, I'm taking the cube root of 125y cubed. For B, I'm going to take the cube root of 8z cubed. Anybody remember what the cube root of 125 is? 5, exactly. And the cube root of y cubed is just what?
2.
Y. Think about that. 3 and the 3. 3 will go into 3 how many times?
1.
1. So you're left with just 1. Pull it out. Okay. What's the cube root of 8? 2. There's your 2. Okay. And z cubed is what? Just z. So notice now I have an a and a b. Okay. Well, look at what my formula says. A cubed minus b cubed will turn into a minus b. Well, I've got an a and a b. Well, let's put it in there. If it's just going to be a minus b, isn't that just turn into 5y minus 2z? Well, that's nice, isn't it? Well, then it says, hey, I've got a squared. Well, that's just 5y squared. Everybody remember how to do that? What's that going to turn into? How about 25 what? Y squared. Because remember, if you have 5y and we square it, we take the 2 to here and we take the 2 to here. That's another one of your laws of exponents. That's why in your notes, whenever I put in your filled in notes today, the very top of my notes actually have the laws of exponents rewritten out for you. So you can go, I wonder why he's saying this. Because they're all built in. Okay. And then we're going to do a times b. Well, what's a times b? Well, what's 5 times 2? 10. Stay with our formula here. My formula says I got to put a plus next. Have to. That's what the formula states. And then I'm going to put a 10, and then I put a what? Yeah, a y and a z. And then my formula is always a plus on the back end, and then it's going to be b squared, which is just going to turn into what? 4z squared, exactly. And that would be done. Now, could you check this one?
Yeah.
Yeah, once again, it's a very nasty foiling process, but yes, you could check it. Because now. I'm trying to think how to put this. Because every single one of you knows how to do the quadratic formula, could you technically go further with that one? Yes, technically, but not this one because there's another variable involved. Okay, so, but remember, like later on, sometime later on, we'll start solving. Okay, when you get to one of these, remember, you can take the one inside there, that polynomial, that trinomial, you can take it further. So even if it looks ugly, you got that quadratic formula to fall back on. Okay. We good there? Factoring trinomials, notice we're just going through the whole process of factoring again. This should be kind of straightforward and simple. A lot of ways you can factor this one. I'm going to do it pretty quickly. This one, I would do the AC method. Everybody here learned the AC method in previous classes. If you had me, you learned it. This is my favorite method until we got the quadratic formula. If you don't know it, I'll show it to you right now. Okay. I do understand that if you've been to the tutors, they show you some weird little cross method. It kind of works. It does start to fall apart sometimes, but I'm going to use the AC method. Remember, we're just going to say, we know there's a coefficient of 1 here. This is A, B, and C. AC method says we're going to multiply A times C, which is going to give us a 12. I don't worry about the negative right now. I need to find all my factors of 12, which is going to be 1 and 12, 2 and 6, 3 and 4. Like, so I'm doing this pretty quick because this should be reviewed for you. And then let's see here, remembers, when your constant is a negative, what is that going to tell me?
Different signs.
Different signs, and the larger sign is going to be what?
Positive.
Positive, because I look right there, okay? So this right there, when it's negative, it says different signs. And I say, well, which sign is larger? I look right there, and it's going to be the positive. So I can come in here and go, my larger sign is positive. So all of these are going to be positive. All of these are going to be negative. And then I just start doing some math. -1 plus 12 is 11. -2 plus 6 is going to give me a 4. -3 plus 4 gives me a 1. And look what is right here. Isn't that a 1? That's the guy I was looking for. Notice, since there is a pretty coefficient of 1, I'm going to kind of get rid of some of the mess here. When there is a pretty leading coefficient of 1, I can literally come right in here and go, okay, well, I know I'm going to have 2 parentheses. They're both going to have an x because that's the variable we're using. And then notice I have a -3, so let's just put a -3 there. I also have a +4. Let's put a +4 there. Now, can we check ourselves? Yes, because I can come in here and go, hey, -3 plus 4, that gives me that 1 in the middle. -3 times a +4, doesn't that give me the -12? It works. Or you could FOIL it all back out and you would get that guy again. A lot of ways to check yourself. Same method for the second one. Okay. I don't want to get, like I said, too hung up. But I would do what? 6 times what?
Well,
Yeah. 6 times 12, what's that going to be? Maybe we'll do that in your head real fast. Just joking. Go do something good. 6 times 12 is going to be 70. I'm the most horrible mental math person you'll ever meet. I'm a very low level math teacher. I'm like, I like the calculator. So I do the same thing again. I'm going to kind of give us some slack. But you're going to need to go back in there. If you're doing the AC method, you're going to need to go right in there and start looking for every single factor. Now, remember, we are factoring right now. We are not doing what? Solving. So yes, you could use the quadratic equation on this, but remember, quadratic equation is going to give you x is equal to this number and this number. to factor it, you have to back it off. So like it said, x equals 2. You'd have to subtract 2 from both sides, get that thing equal to 0. And so therefore, yes, the quadratic formula works fine for this. Just back it off by one step. Because the quadratic formula solves, it does not factor. Okay, so if you decide to use it, if not, AC method is right there. And if you did it and did it long enough, you would get an 8 and a 9. And I know that one works because once again, this tells me what? Different signs, and the larger one is going to be negative. And if we do this here, if the larger is negative, that means my 8 is positive. 8 minus 9 does give me what? That -1 that is sitting right there, and that's the guy I'm looking for. Okay, but the only problem is now what? You got a coefficient of 6. That means you can't just plug everything back in. Okay, like we just did with that pretty coefficient of 1. We've got to come back in here and rewrite this, and we're going to be factoring by grouping now. So I'm going to have 6x squared minus 8x minus 9x minus 12. Once again, like I said, I'm factoring by grouping. Notice that.
Plus 8x?
Was that?
Would it be plus 8x?
It would be. Thank you very much. Thank you for catching that. Eventually I get number blind. You'll call me on stuff, trust me. What am I going to pull out of that first one?
2x?
Very good. Pulling the 2x out. So I'll pull a 2x out, come back up in here, do this part if you need to, does help you out. 6 divided by 2 is just going to give me a 3, and then an x, and then a plus. 8 divided by 2 is going to give me a 4. How about the next one? What do I have to pull out?
Negative.
Gotta pull that negative out. That just needs to become a thing. You just see it, you're like, gotta pull him out. But then negative what?
3.
Yeah, sounds good to me. Let's see if it works. You know pretty quick if it does, right? Negative and negative make positive. 9 divided by 3 is 3. Leave the x. And then how about a 4? And then look, those match. If those match, I can guarantee you this. You've got it right. Okay. But then you come in here, finish it off, 2x minus 3. And then you've got what? 3x plus 4. How would you check that? If you decided to go ahead and you're like worried, pull it back out, you're good to go. And then we have perfect square trinomials. On this perfect square trinomial, I give you a picture from your textbook, which is why we call them perfect squares. Do you remember? I get it. I'm making you think back 3 weeks. Okay. One of the very last lessons in factoring before we got to the quadratic formula was completing the square. So whenever you did it, you would factor out one side to have a perfect square. Okay, because it always factored into like x plus 1, or x plus 1 squared. Okay, well, the reason being is because it looks like this right there. That's a perfect square, and it is given by that formula at the very, very bottom. Okay, or actually, I'm going to rewrite the formula into one formula, this top one here. Okay, this one they give you 2 formulas. I'm going to give you one. It will look like this: a squared plus or minus 2, sorry, my thing blinked on me again. AB plus B squared will always factor into A plus or minus B squared. Let me show you what that means. I'll give you an example below. You don't have to worry about the square. This is more, like I said, I want you to be exposed to a little bit deeper math, because once upon a time, you didn't have formulas. People did not understand formulas. That didn't come around until like the 1800s. So pretty much almost all the math that you saw prior before that was done geometrically. Everything was done by a guy going, I have a square. How do I make a perfect square out of this? Okay, and so they'd have to draw it and measure, and they go, oh, well, this is how this works. And so everything was proven, derived from geometry, until later on when people like Descartes came along and said, Man, I hate geometry. How can I turn this, and I'm just joking and say that, but still, how can I turn these into formulas? And yes, there were variables and stuff, but they didn't have to use them as much anymore. So let me show you an example here. This is an example of a perfect square trinomial. Well, how do I know? Well, first off, let's look at what the formula says. Okay? The formula says this. If I have something of the form a squared plus or minus 2ab plus b squared, right? And that will always factor into something a plus or minus b squared. I want you to look at something. Could I not rewrite this? Look at the first term here. Look at the x. Could I not rewrite this as x squared? And look at the last term. Could I not write the last term as what? 5 squared. But then look at the middle. I'll put a plus symbol there. That's where that plus or minus comes from. I basically look at the second. Is there a plus? I put a plus. If there's a minus, I put a minus. Well, isn't that 2 times what? And what? You've still got a what? What's your leading coefficient? A 1. So there's still a 1 there, but the square root of 1 is 1. So wouldn't this just be 2 times 1 times 5? Okay, and don't forget there is an x. Okay. So what's that going to turn into? X squared plus 10x plus, 25. So if I know my a is actually just an x, right? Wouldn't this just factor into what? X plus 5 squared. Take the square roots of your coefficients on either side. Okay, if you notice perfect squares, multiply them together. 1 times 5 is, no trick question, what is it? 5, I think it is. I'm scared for a second. Multiply that number by 2. Always by 2, you get a 10. There it is. That's a perfect square. And so that's what it's going to factor into every single time. Now, good news. If you don't see it, you first off, practice it until you see it. It's going to help. 2, AC method works just the same way. You could have done the AC method on this and it worked just fine. Because look, 1 times 25 is going to give me 25. Long story short, I only really got what? 1 and 25 and then what? Yeah, 5 and 5. Same signs, that's that plus. That when the constant is a positive, it's same signs. Both of them positive. Well, look, I've got x. Well, that does equal to the 10, right? Well, doesn't that just turn into x plus 5? X plus 5 or x plus 5 squared. Does that make sense? So it works. Okay. Good thing to know. It goes backwards. So instead of having to FOIL all the time, if you see something like this, let's say you see 2x plus 3 squared. Let me erase it to give myself some room here. Now you could easily break that apart, couldn't you? And FOIL it. But look carefully. So put the formula here. The formula says I have an A and I have a B. Well, doesn't that just mean I have a 2x squared? I have a plus symbol. And then I have what? 2 times what? 2x times 3. Plus my b is just going to be 3 squared. So doesn't this just turn into 4x squared? Well, 2 times 2 is what? 4. 4 times 3 is 12. X plus 9. It works both ways. Or could you just break it apart and foil it? It's up to you, okay? I liked playing with the formulas. The reason being is because later on, if I have a formula do something for me, that's less messiness later. Okay, just kind of help me out a little bit, okay? We good? Do that one on your own. And then I'll play catch up. I'll give you a couple of minutes here. Let's see. I do have, we won't be able to go through, I do have quite a bit of homework help on this one in your notes. Whenever I download your notes later on today, you will see a few more homework questions that are just not in your, they won't be in the video. So please make sure to look at your notes whenever I download them. I will not eventually let you know I'm doing that. Okay, so.
It's like the one you showed us at the beginning of class.
Just exactly like it, yep. On your homework, it's going to state, hey, I'm gonna show you a whole bunch of different stuff, from factoring to everything else. And then we go in here and we just start playing with it, so. Choose that. Is it factorable? I don't know. We can worry about that later. Factorable is one thing, solvable, is it solvable? Quadratic formula. Everything's solved before you, remember that, okay, everything is solved, if it's quadratic, everything is solved before you run out. By the end of college algebra, everything will be solved before you, doesn't mean you wanna do it. And a lot of times you're gonna be like, oh, I will go to a calculator, or I will go to a computer, but we're gonna be doing some pretty high powers by the time it's all said and done. How about that one? What does that look like? Does that look like a difference of two squares, square of a binomial sum, or a square of a binomial difference? Well, first off, can we get rid of the difference?
Yes.
Because do you see a difference in there?
No.
No. A square of a binomial sum is the same thing of them saying this, a perfect square. Okay, so what are we doing? Remember that perfect square trinomial? Let me square it, go all the way up. Perfect square trinomials are the same thing. They're using just a different word. Okay, you have a square of a binomial sum, it's plus. Square of a binomial difference, it's minus, but it's still a perfect square trinomial. So this one right here would be the square of a binomial what? Sum, exactly. So once again, two different ways to do this. Okay, one way you can use the formula, okay? Or you can just come in here and do what? Could you not just come in here and do x plus 2, x plus 2? You should all know, and I do not want to go without saying it, you should know that you cannot do what with that power? Distribute it. You cannot distribute that power into there. There is no law of exponents that I've ever shown you that says, hey, if you have a power, you can distribute it in there when there's a plus or a minus on the inside. Okay, can't do it. Okay, that plus or minus stops that. So notice if you want to do the FOIL method on this one, you can. Whenever you look at your notes later, you'll see that I did use the formula and, did I use the formula on this one? Yeah. No, I did both. Except I did the both as a check. Notice we can come in here, we've got x squared plus what? Plus 2x plus 4, and that will simplify into x squared plus 4x plus 4. Notice that does fit our definition of a perfect square trinomial. Let me prove it to you. The square root of 1, which is my leading coefficient, is what? 1. The square root of 4 is 2. 1 times 2 is what? She's trying to trick me. 1 times 2 is 2 times 2. What do we have in the middle? The 4. Notice it's a perfect square. Okay. Which is why it factors back to x plus 2 squared. Because if you did the AC method, you would obviously get the x plus 2, so on and so on. Oh, let's see here. Do we have time? Yeah, we can finish off with this one right here, and the rest of them are, yeah, super simple. But like I said, there's about 2 or 3 more questions. Whenever I download your notes today, 2 or 3 more questions, but let's finish up with this one right here, because that's always a nice one. When factoring, hear me out. I said this in intermediate, I've said it in elementary, and I'm gonna say it again in college. Look for the common GCF first, or the GCF, or the common monomial. Always look for that first. One reason, it makes things simpler. Second reason, sometimes there may be a formula hiding in there and you can't see it until you factor something out. Okay, so let's look at this guy very carefully. Like I said, we'll finish up with him today. Do you see a common monomial? Well, rule number 1 also is what? You always got to factor out a what? Negative. Gotta get that negative out of there. So a GCF is going to be a negative, and you were right about the 5. And what did you say, y cubed?
Yeah.
Yep. And don't forget your negative. And there he is. So let's come through here, knowing what we gotta do here, and you know, okay, I'm gonna write that negative 5y cubed here, and then come in here and divide everything by negative 5y cubed. Be very careful, be intentional with everything you do in this class. You're gonna realize that going fast in this class does not help you. Slow and intentional wins the game, okay? Negative and a negative make it positive. 15 divided by 5 is 3x squared. The y cubed is gone, right? Reduced out, not canceled. Then I have a plus, but then what do I have?
X.
Just x, exactly, very good. And then I have a negative, and then what?
4.
Or what?
4.
That's it, right? Are you done? What should you probably check? How about that guy? Remember, you have ways to factor. Let's see if we can't factor that a little bit further. Let's do the AC method on that one real quick. How about 3? This is the AC. Remember, we got an A and we got a C here. So let's do 3 times 4. That's going to give me a 12. Is there any factors of 12? Okay, remember, I'm looking at different signs. The larger one is negative, right? How about negative 3 and 4? Well, negative 3 plus 4. Give me what? There's that 1, right? So let's go ahead and factor that inside real fast. I've got 3x squared minus 3x plus 4x minus 4. We're factoring by grouping. This front one, I'm gonna pull out of what?
Yes.
3x, and that's gonna leave me with what? X
1.
minus 1, exactly. How about the next one? What can I pull out? 4, and then I get what? X minus 1 again. And then notice my final answer. Got to put it all back together very carefully, right? I have this negative 5y cubed. And then I've got this 3x plus 4, and then I've got x minus 1. And so where do I see people mess up a lot? They forget him. Because he's up there, you don't have to do nothing with him, you forget all about him, but you forget you're factoring, you need him back. Because if I wanted to check my answer, I would need to what? Distribute that back in and then foil it, or foil it and then distribute. It's really however you want to do it, but it's got to get back up to the main, back to the main equation. Okay, or main expression in this case. Good. Now, if we were solving, that's an important thing to remember, that that's going to need to be there. But if we were solving, which we will be doing, if you factor out a constant, you don't have to worry about it anymore, because when you factor out constants, they just kind of just go away. Okay. How do we feel? So far, so good. Still kind of review. Looks a little bit more wicked than it did in intermediate, a little bit, mainly because of the more variables. Okay. Especially being that we just went through in one little lesson about what, 2 chapters in intermediate and like that. So, like I said, don't forget about scanning the QR code for your attendance every day. 2, remember, if you don't show up for a week, I academically drop you. I don't do it during the semester, but I will do it during the summer because there's no reason to be here. 3, get into Hawks fast, okay? If you're not in Hawks by Friday, I will start taking points off on your self and community grade. Okay, remember that's one of those little free quiz grades you get. But that's because that's where I will record all your grades, your attendance, everything. So you need to get in there ASAP, even if you don't have the money right now. Let me tell you, you get 14 days free. Okay, so that's a lot of class. You can get them. I had a student one semester finish the whole class in 2 weeks because he didn't want to pay for it. I wouldn't suggest it. He did it. He passed, I think. So, all right. If you have any questions, please feel free to email. Remember, there's no office hours, but the lecture will be loaded later today, probably around 1, 2 o'clock, and then my notes will be loaded around the same time. So you'll be able to go and look at all my notes. They're a little more detailed, so you can look at some more if you missed some things. Okay. Have a great day. And I'll see you tomorrow.